Okay, so this is what I was talking about on a diagram of the eye. We're going to look at this a little bit and talk about how these diverging and converging lenses are used for eyesight. Just a few little things about the eye real quick. Let me move this out of the way over here. This is the lens in the eye, and it is a converging lens. And so what's expected to have happen is your eye expects to have the rays of light converge back here on the back of the eye. This is where the focal length is going to make that happen. Okay, if the focal length is correct, if the curvature of the lens is correct, and the size of the eye is correct, and all that. Okay. Back here it says this fovea centralis. This is where you get the sharp image for your eye, especially to see a lot of detail. This has to be really closely set, and it's part of this retina area right back here, which is what allows us to see. It's how images are translated through rods and cones for your optic nerve, which is right here. Okay, this is where all those rods and cones are, and you have 3 colors of cones. I'm going to let you see if you can tell me what those colors are at school. Catch me and see if you can tell me. They're the 3 colors of additive light, which I think you should figure that out pretty easily. So anyway, but that is kind of how this should happen. Okay. Now what happens for a converging for what's called myopia, which is the more common eyesight problem that people have. That's the eyesight that I have, is myopic or nearsighted. Okay, is your eye gets misshapen and it's too long. Okay, so what happens is basically is your eye with astigmatism, or if you're basically nearsighted in general, your eye's probably more oval shaped like this. Okay, and so if the focal is hitting here in this area, or the focus is making it converge here, and this area of your retina is actually way back here, that means that your light's not converging where it's supposed to, and you end up with an image that's out of focus because it's hitting right back here. Okay, so what you do is you put in another lens, and you put in a diverging lens. Okay, and this diverging lens that you wear as glasses spreads the light out a little bit so that when it hits the lens, it's going to be further out, and therefore it's going to converge back here on the back of the eye like it's supposed to, because it's spread out further to start. Okay, and so that's using a combination of lenses. Again, it's myopic, and what happens, let me go ahead and use a brighter color, maybe it's easier to see, but what happens is that allows the light to focus on the back because it has been spread out further to start. Okay, it's not as close together as start, so it has to go further back to converge, and that's how that's used. Okay, myopic, which is nearsighted, and that's diverging. Okay. Okay. Again, this is the eye diagram. We talked about this being the light. This is where you, through that converging lens, want the light to focus. Now what actually happens with this type of a lens and with this type of situation is if you are farsighted, okay, farsighted is known as hyperopia. Okay, again, farsighted. This is what happens to people when they get older. They have to wear bifocals. They can see up close, but they can't see far away. That's farsighted. What happens with that, we talked about this a little bit ago in nearsighted where the eye gets longer. What happens with farsighted is the eye may misshape this way, more of a vertical type of oval. Okay, kind of shortens up this way and squishes in this way, and that's one possibility with a farsighted person. Really what tends to happen mostly with a farsighted person is that this lens right here with these these little muscles and everything, and the lens is very it's organic. It can kind of flex and move and everything. You can focus this lens. As you get older, the fibers become a lot more rigid and they don't focus as well, so they can't allow the light to change as far as distances very easily. And if you're just farsighted in general, it most likely because your eyes kind of squished in like this. Instead of growing long, it grew short and then high up and down. So what happens is, again, that light is trying to focus. Let's get a straighter line. It's trying to focus back here like this when you're needing it to focus up here. Okay, and it's focusing too far back. So what you do is you put in a converging lens. So if we were to draw, some type of a converging lens out here, okay, where it's bold out or double convex or whatever on both sides, that converging lens allows the eye to bring the light in a little bit closer to start. Okay, so the light's coming in closer, which is opposite of the diverging lens, so now it doesn't have as far to go to converge, and it's able to converge closer right back here on the retina, and when it does that, you're able to focus again. Okay, that's the basic gist of what goes on with farsighted hyperopia as well as nearsighted, which is myopia. Alright? Okay, so we'll call that good. Again, see if you can catch me and tell me why you see certain colors and what colors the rods, or actually the cones are. The rods are all black and white for brightness, but the cones have specific colors. See if you can tell me what those three colors are. Alright, thanks.